Hey everyone! In today's lesson, we're going to talk about how to determine the scale factor. So scale factors are used when you were talking about similarity, and specifically we're going to be talking about similar triangles. Basically, the purpose of a scale factor is when you want to use the information from one object to get information about the other. And a very simple example of this is the scale on a map, because you can find the distance between two cities on the map with just measuring with your ruler. And then you can use the scale at the bottom to find the actual distance between those two cities. We're going to talk about applications of using scale factors in similar triangles later on this week. Essentially, to find the scale factor, you first need to match the sides with each other. Okay, so let's look at our first example here. Basically, in order to do this, we need to be looking as well at the angles if it's not obvious. Okay? In this triangle, these pairs of triangles, it's pretty obvious that they are in the same orientation, they're lined up the same way, okay? If it wasn't obvious, you could look at these symbols in the corners that are telling you what matches up with what. The 2 matches up with the 2, the 1 and the 1, the 3 and the 3. Okay, and so to match up the sides with each other, I'm going to look at the sides opposite each angle. So I'm going to say, okay, the side opposite my little 1 loop there, I'm going to make blue, and so that has to be this side as well. Then I'll do, okay, the side that's opposite the 2 lines, well, that's going to be green, and so therefore this one has to be green as well. And finally, the last side then has to match up with each other. And again, if the triangles are obvious, you don't need to go through that kind of mental process, but it's helpful to think about it. Then what we need to do is divide the larger side by the smaller side. And because we are dealing with similar triangles, it doesn't matter which one you choose. So I could do 12 divided by 6. I could do 20 divided by 10. I could also do 14 divided by 7. All of these things equal 2. So it doesn't matter which one you're picking. And so I can say, therefore, the scale factor is 2. Let's look at a second example here. My first triangle has 18, 16, and 20. And my second triangle has 22, 20, and 25. Let's go ahead and match up some sides right to begin with. Okay, I'll do the side opposite my single loop as pink. I'll do the side opposite my double loop as blue. And I'll do the side opposite my triple loop as green, or the last remaining side. Again, in order to find the scale factor, I just have to do one number divided by the other, so I can do 20 divided by 16. I'm going to reduce this fraction by dividing the top and the bottom by 4, leaving me with 5 divided by 4. And 5 divided by 4 is 1.25. So our scale factor is 1.25. Again, there's going to be decimals, there's going to be whole numbers, it doesn't really matter as long as you're doing the math right. And again, it didn't matter which sides I picked, because they're similar triangles, I would get the same answer. Let's look at our last example here, okay? Here we have them, and they're obviously not in the same orientation. One is flipped around from the other. The first thing that I'm going to do is start by matching up the sides, just like we had done previously. So I'm going to say the side opposite my single loop is going to be blue. Therefore, the side opposite my single loop on my second triangle also has to be blue. Now let's do it for the double loop. The side opposite my double loop is going to be green. And this side opposite my double loop is also going to be green. Finally, the side opposite my triple loop will be pink. So you can kind of see that one is a reflection of the other. They've spun around. And for some people, it's really difficult to imagine how these two triangles can possibly be similar, when not only is one smaller than the other, but they're flipped around and they're not in the same direction. If this is the case and I am one of these people, you can redraw one of the triangles to be facing the exact same direction. So I'm going to redraw my BHP triangle over here so that it follows the same direction as the other one, okay? Now it doesn't necessarily have to be to scale, it just matters that you are drawing with the right. So I'm going to replicate the triangle I have here. So it's an upside down triangle. It's not going to be perfect. Okay, and then I'm going to say this is 1 loop, this is 2 loops, this is 3 loops. I can match up the letters as well, so I can say, well, P was loop number 1, H was with 2 loops, and B was with 3 loops. I then can go ahead and I can match up the colors of the sides, so I can say, well, blue is this side, green was this side, and pink was the last side. So I can see now very easily how my top triangle, the triangle given, and my replicated triangle are very similar. Now it's just a matter of writing down the measurements. So I can say, well, blue side was 8, therefore this has to be 8. Green side was 12, therefore this has to be 12. And finally, pink side was 5, so this has to be 5. Now I can go ahead and I can solve my problem and determine what my scale factor is exactly like I had done before, now that I can see my 2 triangles lined up. Let's do the blue side. So my scale factor, we have to go from 10 to 8. So my scale factor is going to be 10 divided by 8. Okay, if you can't do the math in your head, you can go ahead and do it on a calculator. I'm going to start by reducing this fraction. It is going to be 5 divided by 4. And the scale factor for this happens to be 1.25, just like our previous example. Okay? So remember, when you're finding your scale factor, we match up the sides with each other, and sometimes you might need to redraw your triangle. And then you need to divide the larger side by the smaller side. And that's it.